Hello everyone, welcome back to my channel, and this is Hui. Today we're going to be diving into multi-factor authentication, which is a very common security feature on modern applications. So without further ado, let's get started. As you can see on my screen right here, I'm on a room on TryHackMe, and I have already started the target room. Make sure that you modify the host file right here as I did on my screen to make for the following exercises. So what's multi-factor authentication, or MFA? It's a security feature that adds another protections onto the authentication processes. So there are different types of authentication factors. Something you know, this can be your passwords, the PIN numbers, or any piece of information that you know. Sometimes it can be like the answers to your security questions. Something you have is gonna be the phone with the authentication app, a security token, or even a physical card for your bank account. Something you are. This is something like biometrics, fingerprints, or iris scannings. And because everyone has a unique biometric data, this form of authentication is getting more popular amongst the applications and organizations. Somewhere you are, this involves your original IP address and geolocations. Depending on where you try to access the applications, certain services will be limited or restricted. Something you do, this kind of authentication is usually used in applications that restrict bot interaction, like registration pages. The application typically analyzes the way user input types credentials or move the mouse. So this is very popular when you try to log in certain pages or try to sign up for pages on applications. Sometimes you have to prove that you're not a robot, or you have to fill in the recap to complete the recaptures. Yeah, I know those traffic lights, or choose the images with a has of a motorcycle, which is a tiny little bit corner of the pixel of the square. Okay, never mind. Let's get back. So, two-factor authentication, or 2FA, is especially is sorry, 2FA is specifically requires actually two of these factors. And so it basically is a combination of any two of these authentication factors: something you know, something you have, something you are, somewhere you are, and something you do. It's any combination of these five. There are different kinds of 2FA: tab-based one-time passwords. These are the temporary passwords that change every 30 seconds. So this has been getting popular. Like, you sign up for the app, and then you're gonna be registered you scan a little bit QR code onto the authenticator app, and then every time you try to access an application, you're gonna be prompted a 30-second 6-digit security code, and they just randomly generate it every 30 seconds. Push notifications. A lot of us use Gmails, and when we try to access our Gmail accounts from from an unusual location, then we'll be sent a notification that, hey, you try to access your account from this location. Can you confirm if it's you? And then sometimes you may do extra step by confirming a number that you got sent to your trusted device. SMS. This is similar to the TOTP, or the time-based one-time password, that when you try to, after you input your credentials, your username and password, you're gonna be asked to enter a security code, which will be sent through your phone. Now, for usually this code is 6 digits, and then it's only valid for about 10 to 15 minutes, and after that you have to request another code. Hardware token. Hardware token. Devices like YubiKeys generate a one-time passcode or use the NFC authentication. They are great because they don't need any network or battery, so they work offline even better. Sorry about that. Conditional access. So conditional access is typically used by companies to adjust the authentication requirements based on different contexts. So depending on the services and depending on the geolocations when you try to access the applications, you may be restricted to some features of the applications. Location-based. If a user log in from the user location like the office, then they might only need to provide their regular credentials. Again, this must be very common to a lot of you guys, and then you may be very familiar with this. So when you try to when you go to work, you access your work email from the office. Username and password are the only thing you need. But if you try to access your work email from, let's say, from your hometown country when you're on vacation, then you're gonna be prompted to enter additional security code. Time-based, the same thing. You try to log in your work email around from 9 a.m. to 5 p.m. Let's say that's the regular working hours, right? On your username and password would be enough. But if you try to log in your your work emails after the working hours, then you may be prompted to enter additional security code. Behavioral analysis. So let's say you try to access sensitive information where you don't usually access to, then it's gonna be asked you for another type of authentication to make sure that it's really you. Device specific. In some cases, companies don't allow employees to use their own device to access corporate resources. This is true. So you try to log in your work Gmail, you won't be able to do it. You have to use the company's phone or laptops to do it. So let's answer the questions. When logging onto the application, you receive SMS on your phone containing OTP. What authentication factor this is? This is gonna be something you know. Okay, now let's move on to implementations and applications. MFA has become very popular nowadays, and then it's becoming the standards for the best practices when it comes to security for the authentication processes. MFA in banking, in healthcare, in corporate ITs, they use everywhere. I use my bank. Every time I try to log on to my bank account, I have to input my security code. Back in my work day, so when I try to access my work emails, I always have to authenticate myself with, the security code that provided by the companies. So it's obvious. Is MFA an important factor in keeping our online and offline activities safe for threat actors? Yeah, of course. Common vulnerabilities in MFA, the OTP generation algorithm. The security of the one-time password is only as strong as the algorithm it used to create. So if the algorithm is weak or too predictable, it can make the attacker's job easier to try to guess OTP. Application leaking in the 2FA token. If an application handles data poorly and has vulnerabilities like an insecure API endpoints, it might accidentally leak the 2FA token in the application's HTTP response. Due to insecure coding, some applications might also leak the 2FA token in response. A common scenario is when a user, after login, arrives on the 2FA page, the application will trigger an HR request to endpoint that issue OTP. Sometimes this HR request return the OTP back to the user inside the HTTP response. We'll go over this vulnerability later on today. Brute forcing the OTP. Even though OTPs are designed for one-time use, they are immune to brute force attack. If an attacker can make unlimited guesses, they might eventually get correct OTP, especially if the OTP isn't well protected by additional security measures. So this is true because the security, most of the time, the security code is only 6 digits. And then for human trials, then it might be hard because we have a combinations of 10 to the power of 6 combinations. But if you use automation software, then it should be a piece of cake. And then for hackers, automation is automating this attack is a piece of cake. lack of rate limiting. So this is one of the reasons why we have to have the rate limiting in the in the multi-factor authentication implementations, because without this, attackers can try as many guesses as they want until they get the correct 1TP, that they get correct security code. So usage of the Evil Engines. Evil Engine is a tool that is typically used for red team engagement. It can also be used to execute sophisticated phishing attack, effectively bypassing multi-factor authentication. It operates as a man-in-the-middle attack proxy that can intercept the redirect OTP meant for the legitimate user. So like as it states right here, you intercept the traffic, analyze the traffic, and then see get the OTP code when the server tries to send it to the clients. What can be implemented to help prevent the brute forcing OTPs is rate limited. So the account or the user should be locked after a certain number of failures. Ideally, it should be 5. Okay, let's get into the exercises. OTP leakage. So as we discussed earlier, right here, the application leaking the 2FA token. If an application handles data poorly or has vulnerability like insecure API endpoints, it might actually leak the 2FA authentication, 2FA token in the application HTTP response. So in this case, XHR, or which is known as the XSML HTTP request, is the main protocol that the server uses to communicate with the clients, to exchange the OTP code. And then because of some insecure coding or bad practices during the implementations, this response is displayed on the client side, which can be accessed by the users and attackers. So let's try to see how it works. Also, another reason why this piece of information is displayed is debugging information left in production. Sometimes when we try to test this on staging, we need this information to display so we know what's going on with the response or with the traffic. But for some reason, the QA testers or the developers, they forget to get rid of this kind of information, and then the code is deployed to production. This is where the OTP is leaked to regular users, and then attackers might take advantage of it. So let's try to visit the first exercise. It doesn't work. Okay, hold on, let me see what's going on. Is the IP address correct? 10.10.182, yes, that's correct. And then MFA TryHackMe. Oh, slash, sorry. So try to log in as the full username. TryHackMe mail.tryhackme, and then password is going to be test123, and then you're going to be inspecting the network tab. Log in. Now, as you can see, after you input the correct username and password, you'll be landing on the MFA page where you'll be prompted to input the security code. And over here, if you get notice, like in the network tab, you see there's a get request for MFA page, and then there's also a post request right here. This is where the token gets leaked. And if you double click that, you see the token is 9579. 9579. And we'll be able to log in. That's it. It's simple and easy. So next time when you try to do a pen test on web applications and you prompt MFA, it's worth checking the network tab, because sometimes you might see the token right there, the code right there. Now let's move to the second one, insecure coding. So logic flaw and insecure coding. In some applications, flaw logic or insecure coding practices can lead to a situation where critical parts of the applications can be accessed without fully completing the authentication process. This is true. Like sometimes you input your username and password, and then even though you prompted to enter the security code, you can actually ignore that and then go straight to the page if you know the URL. So in this case, like for example, in this case, let's try a second. TryHackMe at no, it should be TryHackMe and test 1 2 3. Now over here, as you can see that even though you land on the MFA page and you're prompted to enter the security code, but because you know what the URL is, you can actually try to access it without inputting the code. So dashboard, and boom, there you go. Now you'll be surprised that many applications still do this, so it's also worth trying. And then I'm not sure why. I don't know why a lot of companies or developers they don't take time to actually test these simple features. But yeah, I've seen this a lot. And then over here you're gonna see the details of the code. This is testing the application from the white box. This is white box testing, so you have access to the source code, so you're testing applications from the white box perspective. Now let's go. The next vulnerabilities is brute forcing the OTP. Like I mentioned earlier, OTP is easy to brute force if you don't have the rate limiting. So because attackers have infinite amounts of guesses, they will be able to crack the OTP quickly. And in this case, no, because it's only 6-digit numbers. It's a 6-digit number, so using automation tools can easily break the brute force the code, and then therefore bypass the multi-factor authentication processes. And in some this is easy concept. As you can read it, it's easy to understand, so I'm gonna skip it right now and go straight to the exercises. So I'm gonna try to explore the application using the script provided by TryHackMe. So first of all, I'm gonna copy this one. I don't need to. Okay. And then let's try running that in a terminal. Oh wait, let's see what I think I need to modify the URL. So hold on a second. Oh, I just have to. Everything is set. So let's try to run the code. Okay, as you can see right here, after several attempts, then you finally you're able to get access to the page with a session cookie right here. Let's try to log in with the session cookie. Now copy this one, go to the application storage right here, cookie section, and try to place the value, and then refresh the page, and you're logged in. So basically what the code does is it tries to brute force the OTP, the security code, the OTP, and then once it successfully logged the user in, it will provide you the section IDs, and then you can use that section, the cookie or section IDs, to actually log in the dashboard. And here's a fact that we have. And that's it for the room today. Thank you for listening, and then sorry for all the hiccups I have. These are my very first few videos, and I'm trying to get used to it. If you love my videos and love to support me, please subscribe to my channel, and hopefully I'll see you soon. Thank you.